The arrival of raw titanium is the critical first step in creating the heart of a jet engine. Each ingot must be verified.
Temperature holding steady at 1900 Celsius.
Acknowledged. Maintain current flux until the lift cycle completes.
This scene is part of the manufacturing process for the turbofan jet engine. Gigantic 5-axis CNC mills.
This scene is part of the manufacturing process for the turbofan jet engine. Robotic arms refine the blade surfaces to a mirror finish.
The alignment on this segment is within tolerance.
Confirmed. Ready for the next layer.
The titanium leading edge strips are heated and then precisely pressed onto the composite blade edges by the robotic alignment fixtures.
The ultrasonic scanners meticulously map the blade's inner structure, projecting a real-time cross-section onto the holographic display.
The titanium blades undergo a meticulous polishing process, resulting in a flawless mirror finish before the anti-corrosion mist is applied.
This molten alloy bath provides the critical protective coating for the blade roots, allowing the turbofan engine to withstand extreme temperatures during operation. Under enormous pressure, the raw nickel titanium alloy is forged, becoming the heart of the fan module. This is the crucial stage of compressor blisk forging, where a single piece of metal is shaped under incredible force.
This scene is part of the manufacturing process for turbofan jet engine.
As the thick abrasive slurry pulses through the blisk channels, it scours the metal, resulting in this mirror-like perfection.
Here we see the robotic arms meticulously inserting the stator vanes, a critical step in the turbofan jet engine manufacturing process.
Multi-axis robotic presses shape the heat-resistant alloy into curved segments for the combustion liner.
Utilizing high-temperature robotic welding, multiple liner panels are joined to form the perfect circular structure of the combustor segment.
The precision of the laser alignment rings ensures concentricity, a critical step before the final torque sequence.
This scene is part of the manufacturing process for a turbofan jet engine.
The injector array shows perfect concentricity.
Confirmed. Proceeding with the manifold attachment. This scene is part of the manufacturing process for turbofan jet engine. Electron beam machines drill microscope.
This scene is part of the manufacturing process for turbofan jet engine.
This scene is part of the manufacturing process for turbofan jet engine.
As the robotic grinding wheels sculpt the blade roots, precision lasers ensure the dovetail shape.
Massive nickel discs are forged in industrial presses capable of thousands of tons of force. The metal glows white hot.
Each turbine blade slides into a dovetail slot with the fit. Robots locking features into place.
Inside the vibration tunnel, sensors paint holographic stress maps over the rotating stage, revealing critical vibration signatures.
Axial clearance on stage 7 is holding at 0.02.
Confirmed. The alignment is perfect according to the hologram data.
Using advanced robotic fixtures, the stator vanes are precisely locked into the turbine housing, ensuring optimal exhaust flow.
To withstand extreme temperatures, the nozzle guide vanes receive a specialized thermal barrier coating.
This scene is part of the manufacturing process for turbofan jet engine.
Alignment confirmed. Proceeding with the final locking sequence now.
The core casing is secured by hundreds of titanium bolts, tightened in a precise, rhythmic sequence by the robotic torque tools.
Alignment is confirmed. Proceed with the lubrication flow test.
Initiating drivetrain engagement sequence. Data looks nominal.
This scene is part of the manufacturing process for the turbofan jet engine.
This scene is part of the manufacturing process for turbofan jet engine.
The massive fan assembly, with its gleaming titanium composite blades, lifts via overhead crane and slowly The inlet guide vanes are crucial for optimizing airflow. Here, robotic arms use lasers for precise calibration.
This scene is part of the manufacturing process for the turbofan jet engine, where curved panels are formed from high-strength aluminum.
This scene is part of the manufacturing process for turbofan jet engine. This scene is part of the manufacturing process for turbofan jet engine. The Full Authority Digital Engine Control, or FADEC, is installed next. This critical computer stations. The precision of the robotic arms ensures every wire is perfectly crimped before being routed into the armored conduits. connections. The wiring harnesses snake across the engine core, held by metallic brackets and heat-resistant wraps.
The thrust reverser tracks are critical safety components. Here, the robotic arms apply a specialized lubricant
Okay, ease off slightly on your side. Copy that. Still spinning freely.
This scene is part of the manufacturing process for
The turbofan engine, now complete, begins its journey to the outdoor test facility.
Connection secure. We are clear on this side.
Confirmed. Retracting and moving to console.
Fuel pressure is optimal.
Confirming turbine RPM stable. We are ready for sequence start.
The combustion liners look completely sound.
Yes, and the turbine blades show zero signs of distress.
Hydraulic clamps release as cranes lift the engine from the steel test structure. Fuel lines disconnect with controlled precision. The engine has reached its idle speed. As the fan stabilizes, the green sensors confirm optimal performance.
The baseline signature matches the low RPM output.
Cross-reference with the historical data set.
This scene is part of the manufacturing process for a turbofan jet engine. The engine roars louder as fuel.
The curve is tracking exactly as expected. We're almost within the green zone. Good, the thermal stress phase is complete.
This thermal stress evaluation pushes the turbofan engine to its limits, revealing critical heat tolerances.
The spectrometer analyzes the oil for microscopic metal particles, ensuring the engine's integrity.
X-ray diffraction allows us to analyze the crystal structure at an atomic level, ensuring the integrity of the alloy after stress testing.
Structural bolt retorque and fastener inspection. This scene is part of the manufacturing process for a turbofan jet engine.
This scene is part of the manufacturing process for turbofan jet engine.
Each engine receives a unique serial number, ensuring traceability throughout its service life.
All right, bring it down easy. Watch the clearance on the left. Okay, straps are engaged. Ratcheting tight now. We are good to go.
This scene is part of the manufacturing process for turbofan jet engine.
This scene is part of the manufacturing process for turbofan jet engine. All right, stability verified. We are clear for installation.
Hold the position. Adjusting 2 millimeters right.
Confirmed. We have positive alignment.
As the blue calibration fluid flows, we can confirm the pressure gauges are stabilizing smoothly.
Pressure holding steady at 5,000 psi. FADEC initiated.
Confirmed. Interface connection is secure.
IRS mode selectors.
Normal and on DC. Battery voltage and FADEC health checked, nominal.
Confirmed.
The engine has successfully stabilized at idle thrust. All parameters are reading nominal.
During the initial climb, the engines operate at maximum thrust. We closely monitor the turbine temperatures and fuel flow.
At cruising altitude, engine readings stabilize into perfect green lines. The engine runs silently with a smooth hum.
Check the sensor array near the oil port.
Copy that. No anomalies detected on the screen.
Clear to proceed to final stop.
Roger. Technicians are in position on level 3, awaiting power down confirmation.
Fan blades are removed individually and placed into numbered racks, while robotic scanners examine leading edges and composite layers for micro cracks.
The single crystal blade is precisely maneuvered into the dovetail mount, where holographic indicators confirm locking integrity. As you can see, the post-overhaul test is proceeding smoothly. Thrust values and vibration levels are well within the stable operating parameters.
After years of service, this engine has reached its end of life. It will now be evaluated for recycling and component recovery.
The dismantled modules are meticulously sorted. Titanium, nickel superalloys, composites, and steel.
This scene is part of the manufacturing process for Turbofan jet engine.
Check the thermal load on the new casing.
The green highlighted sections are holding stable at maximum thrust simulation.
This scene is part of the manufacturing process for Turbofan jet engine. Recycled titanium